Alright, I'm going to do a couple of problems from today's classwork, Isotopes. So if you need help on these, just go ahead and look at these. I'm trying to do examples from each different area, so as best as possible, so you have an idea of how to complete this at home. The first problem that we're going to look at is number 1, and we're going to look at neon 20. So before we do anything here, I'm going to pull out the periodic table, and we're going to look at the periodic table to get some of the important information from neon. Alright, so when we're looking at neon on the periodic table, here's neon, Ne. This top number represents the atomic number, which is also the number of protons of neon. Then the bottom number is the average atomic mass. For these problems right now, the only number we need to use is this top number, which is the atomic number of neon. So from the periodic table, we have neon, and we just found that the atomic number of neon was 10. So the atomic number goes on bottom when we write the element symbol of an isotope. So the 10 right here, this is our atomic number, and then the top number is going to be our mass number. Now from this problem, our mass number is 20. So 20 will go on top. So now we can use this information to figure out the number of protons, neutrons, and electrons for neon 20. Now just a heads up, or just a little reminder, this number on top, this 20, that is the atomic, or sorry, not the atomic number, this is the mass number, and that is equal to the protons plus the neutrons. And then this bottom number is the atomic number, and the atomic number is equal to the number of protons. Okay, so using that information, we can figure this out. Directly, the number of protons is found by this number on bottom, which is 10. Okay, then for neutrons, we have to take the mass number, which is on top, and subtract the atomic number, which is on bottom. When we do that, we go 20 minus 10, that equals 10. So neon 20 has 10 neutrons in it. And finally, to get electrons, we know that this atom is neutral. So in a neutral atom, we know that the number of protons equals the number of electrons. So in a neutral atom, those two have to be equal. Neon 20 is a neutral atom, so therefore the electrons have to be equal to the protons, so that equals 10. And now you just do the same thing for the following two examples of neon. Okay, for problem number 2, we are going to start by using the information in problem number 1. So we know that neon 20 has 90.5%, and we know that its mass number is 20. Okay, so that's for neon 20. For neon 21, we know that the percentage from the top is 0.3%, and so from that the mass number is 21. And then for the last one, neon 22, okay, we know that the percentage from neon 22 from above is 9.2%, and that number there is 22. So let's start with our equation. M average equals, so the mass number times the percentage, plus mass number 2 times the percentage 2, plus mass number 3 times the percentage 3, and we divide all those by 100. So that's our equation. Now we just plug them in. So we start by multiplying 90.5 times 20. So 90.5 times 20. Put those in parentheses. We add that to 0.3 times 21. And then our third one, we add it to 9.2 times 22, and then we have to divide everything by 100. When we do this on a calculator, we get 20.19 AMU, and this number makes sense because if we look, the isotope with the highest percentage is 20, so we could guess that the average atomic mass should be closest to 20, which it is. It's 20.19, so it's pretty close to what we thought it would be. Alright, the last number that I'm going to do is number 8 on the back. So for number 8, we're actually going to do this problem right here. So we have a few numbers. All it gives us is the mass number and the protons. So we have to work backwards on this. So we know that the mass number from what we did on the front side, mass number gets written on bottom, and the atomic number gets written on bottom, and then the mass number gets written on top. So we have our numbers, but what we need now is to get our element symbol. We need to figure out what element this is. So we're going to use our atomic number and the periodic table to figure out what element we are looking at. So when we pull out our when we pull out our periodic table, we are looking for the element with atomic number 53. So as we go through here, remember atomic numbers are the numbers on top. We get to 53, so that's atomic number 53. Element that corresponds to is iodine. So now we go back over here, and to get the element symbol, we just use a periodic table. We found out that is iodine. Iodine is abbreviated as I, so that's the element symbol. Okay, so now that we've done this, we can start plugging it into our chart. So we've already done this problem, basically. So the 126 is our mass number on top, and then the 53 is our atomic number on bottom. So now, looking at this, the atomic number I just gave you is 53. It's the number on bottom. Okay, mass number is completed. Protons are completed, which remember protons are equal to the atomic number. Okay, the next one are the neutrons. So in order to calculate the neutrons, all you have to do is take your mass number, so the mass number, and subtract the number of protons. Here our mass number is 126, so we go 126 minus, number on bottom is 53, so minus 53. When we do this on a calculator, we get 73. So our number of neutrons here is 73. The last category that we have to do are the electrons. Now remember, these are neutral atoms, so if it's a neutral atom, the number of protons has to balance off with the number of electrons. We have 53 positive protons, so for this atom to be neutral, we have to have 53 negative electrons. And that's how you fill in this chart.